Hi guys, so in this video, we are going to solve problems involving the length of an arc of a curve using integral calculus. So suppose we have here a curve and we are going to determine the length of the curve from a certain points on that curve. So let's say that this curve is represented by S. Now, the first step guys is let's get a differential strip. So this curve is a function of x. So let's get a differential strip. Let's say that it is a differential s, so ds. Now, if we zoom in on the strip, it becomes practically straight. Then the slope of that differential s is given by, you have this triangle. So you have here differential y for the height and differential x for this side. So using the Pythagorean theorem, we have here differential of s squared is equal to dx squared plus differential of y squared. Then you just simplify this. So differential of s squared is equal to dx squared plus differential of y squared. Now, we divide this both side by differential of x squared in order for us to have a dy with respect to x expression. So we divide both sides by differential of x squared. So differential of x squared all over differential of x squared plus differential of y squared all over differential of x squared. So you can cancel this out, so that is 1 differential of x squared all over differential of x squared. So differential of s squared over differential of x squared is equal to, we have here 1 plus the square of differential of y with respect to x squared. Then we raise both sides by 1/2. So we have the square root. So differential of s with respect to x is equal to the square root of 1 plus, you have here differential of y with respect to x, that is squared. Then we multiply differential of x both sides. We have differential of s is equal to, you have here the square root of 1 plus, then this is y prime squared differential of x. Then we integrate both sides to extract s. We have here the integral of differential of s is equal to the integral of, you have the square root of 1 plus y prime squared. You have here dx from, since it is dx, so x1 to x2. We can say that s is equal to the integral of square root of 1 plus y prime squared differential of x from x1 to x sub 2. So this will be our formula here for the arc length of a curve. Then we determine those elements. So we have this curve, x squared is equal to 4y, and we are required to find the length of the arc from x is equal to -3 to x is equal to 3. Now, we first graph the curve. You have here x squared is equal to 4y, therefore the vertex is facing the x-axis. This is either upward or downward. So y is positive, therefore this is upward. With a vertex at 0, 0, you don't have an h and k. So from x is equal to 3 and x is -3. Then this is the length of the curve which is being required by the problem. Then we apply the formula. We have here s is equal to the integral of, we have here 1, so the square root of 1 plus y prime squared dx from x1 to x2. So here x1 is -3 and x2 is 3. We have here x squared is equal to 4y, so we need to find y prime here. So we differentiate both sides. So 2x differential of x is equal to 4 differential of y. So divide both sides by dx. So differential of y with respect to x is equal to, you have here 2x all over 4. Or that is y prime is equal to x over 2. So we have all the elements. Now we can solve this directly. So going back to our formula here, we just substitute all those elements. So the arc length S is equal to the integral of, you have here from -3 to 3, that is the square root of 1 plus y prime is x over 2. So that is squared differential of x. So just simplify this. We have S is equal to, you have integral of 1 plus x over 2 quantity squared from -3 to 3. So that is over 4. Further simplifying, we have, so S is equal to, you have here the integral of, we have here 4 to the square root of 4 plus x squared all over 4. So perhaps we can bring this 4 outside. So the square root of 1/4, that is 1/2. We have here 1/2. You can bring that outside. You have here differential of x. Now, here we can use our calculator to solve this. So directly input in the calculator, we have here 1/2, that is the integral of, so our limit is from -3 to 3. You have the square root of 4 plus x squared. So equals, you have 7.8 units. So that is the final answer, guys. So if you want to solve this in the long method, you can actually use trigonometric substitution. So if you recall our previous discussions, if you have this expression, can be solved using trigonometric substitution as we recall in our previous discussion. So this is 2 squared plus x squared. So your substitution will become, let x be 2 tangent of theta. Then you can solve this in the long method, so manual solving. But you can actually solve this using your calculator. So this application is one of the most awesome application of integral calculus. So all those formulas in plane geometry, solid geometry, those are all derived using integral calculus. So we have this curve that touches your y and x axis. So we have an area here bounded by those axes. So we are required to find this area. The first step is to get a rectangular strip. So it's a strip that actually touches all those boundaries. So this is a rectangular strip. So the whole area is the area A, but if you get a differential strip, it will be represented as differential of area. So it's a rectangular strip. So the length of that rectangular strip is actually your height. So that is y sub 2 minus y sub 1. But y sub 2 can be represented as y upper, and y sub 1 at the bottom, you can represent that as y lower. So it's just like a distance. So distance formula lang yun, guys. And this width here can be represented as dx since it is projected or it lies on the x-axis. So this height here is y upper minus y lower. That is y sub 2 minus y sub 1. And this width is differential of x. So the area is, of course, it's a rectangle. It is length times width. So this is a vertical rectangular strip. So y sub u minus y sub l differential x. So that is our differential of area. Now, integrating both sides, we can extract that area. So integral of differential area is equal to the integral of y upper minus y lower times differential of x. So since we have here differential of x, our limit will be x sub 1 to x sub 2. So the boundaries in x-axis. So this is x sub 1, this is x sub 2. You have here from x sub 1 to x sub 2. So our area is equal to the integral. So this is the definite integral of y upper minus y lower differential of x from x sub 1 to x sub 2. So this will be our area if you're dealing with vertical rectangular strip. So another scenario is we get a horizontal strip. Here we have this curve f of x bounded in the first quadrant. Then the area of that rectangular strip, we have here the length that is, since it is projected on the x-axis, it will be x, say right, minus x left. So x sub 2 minus x sub 1. It's a distance formula. Then you have the width here. Since it's projected in the y-axis, it's differential of y. So differential of a is length times width. So length is xr minus xl. Width is differential of y. So integrating both sides, we can extract the area. So area is equal to, we have here the integral of x sub r minus x sub l differential of y. So we have dy here. So our boundary will be from y sub 1 to y sub 2. It can be y upper minus y lower. So area is the integral of x sub r minus x sub l differential of y. So it's the definite integral. So we have here y sub 1 to y sub 2. So in our first problem, we have here the parabola x squared is equal to 4y. We have here y is equal to 5. And we are required to find the area bounded these two curves. So first step, guys, is to plot the curve. You have here the form of a parabola. You have here x minus h squared is equal to 4ay minus k. So by inspection, guys, we can say that we don't have h and k, therefore the vertex is 0. So you have a positive y. So if your squared is x, therefore the vertex is facing your x-axis. So it's either upward or downward. But y here is positive, therefore it is upward. So the vertex is at 0, 0. So this is x squared is equal to 4y. Then we plot the other curve. Y is equal to 5. So it's a horizontal line. So y is equal to 5. So the area bounded is this shaded figure. So you can decide whether to get vertical rectangular strip or horizontal. So let's say vertical na lang, guys. Vertical. So make sure that your strip will actually touch both curves. So if it touches the same curve, of course your answer will be wrong. It should have a boundary. So here, rectangular strip touches both curves. So this is a good to go solution. You have here the length that is y upper minus y lower. So width is differential of x. Then this differential of area is length times width. You have this length y upper minus y lower, so we have derived this differential of x. So integrating both sides, you have here differential of area. The integral is equal to the integral of y upper minus y lower differential of x from x1 to x2. So area is the integral of y upper minus y lower differential of x from x sub 1 to x sub 2. Now we need to determine all those elements. So what is x sub 1? So x sub 1 is actually the intersection there. So that is x sub 1, this is x sub 2. So those are the boundaries. So we need to determine that x sub 1. So x sub 1 at y is equal to 5. So just input y is equal to 5 in your parabola. You have here y is equal to 5. So substitute in the parabola. So x squared is equal to 4 times 5. Therefore, we have x as the square root of 20 or 2 square root of 5. So we have here the square root. So it means that it is plus or minus. That is plus or minus 2 the square root of 5. So this x sub 1, since it is located there in the left side, it is negative 2 the square root of 5. So x sub 2 is located on the right side. Therefore, it is 2 square root of 5. That is positive. So x sub 2 is 2 the square root of 5. So what is y upper there? So y upper touches the curve y is equal to 5. So therefore, y upper is 5. So y lower touches the parabola. Therefore, we need to determine what is y there. So y is equal to, we just divide by 4, so that is x squared over 4. So we have determined all those elements. So the next step is to just substitute all those elements in the formula. You have area is equal to the definite integral of y upper is 5 minus y lower, that is x squared all over 4, differential of x from negative 2 the square root of 5 and positive 2 the square root of 5. You can use your calculator here, but let's try solving this manually. You have here the integral, the definite integral of, you have here 5, just distribute this. So 5 dx minus integral of, you have here x squared. So put 1/4 outside, so the constant must be outside. This is x squared, differential of x from negative 2 square root of 5 to 2 the square root of 5 is x. So limit is from negative 2 square root of 5 to 2 square root of 5 minus 1/4. So we need to add to the exponent. So this formula is the power formula. So that is x cubed all over 3 from negative 2 the square root of 5 to positive 2 the square root of 5. So we just substitute all these values. So you subtract the lower limit to the upper limit. So we are required to find this area here. So area is equal to 5. So you have here x, so that is 2 square root of 5 minus negative 2 the square root of 5. So you just substitute all those limits and subtract. Here minus, so here 1 over 12. So that is 1/3 times 1/4. So 1 over 12. So we have here x cubed, so that is 2 the square root of 5 cubed. Don't forget your parentheses. So the groupings are important. It's a common mistake of some students. We just solve the value. So we have here 29.81. So unitless, therefore we can say that this is square units. So in the board exam, you can actually input this directly into your calculator here. So that is integral below the alpha button. So alpha x squared all over 4. So just press equals there. It will give you your answer automatically. So it's the same. 29.81 square units. Now guys, we have an alternate solution for this. So for a segment of a parabola, we actually have a formula. So if this length is A, this height is B. So the height from the vertex to the bisecting line segment there. So A is equal to 2/3 AB. So this formula guys is derived using integral calculus also. So this is already formula for a segment of a parabola. You have here 2 square root of 5. So this is negative 2 square root of 5. So the length A must be x sub 2 minus x sub 1. So you have here A is equal to 2 square root of 5 minus negative 2 the square root of 5. So this will be 4 square root of 5. So the grouping is important. It's a common mistake guys. So the height is, so if this line is y is equal to 5, so from 0 to 5. So therefore the distance is, you have 5. So the height is 5. So B is 5 units. And you just directly input it to the formula. So if you're given this type of problem guys, you can either use integral, you can either use the formula. So formula is advisable if you have remembered it. So if you forgot the formula, back to basic, you need to use integral calculus. So area here will be calculator. So that is 2/3 times 4 square root of 5 times 5. So it must be equal. So 29.81 square units. So that is our final answer. So in this next problem, we have y squared is equal to 5x. And we have these lines. X is equal to 1 and x is equal to 3. So you're required to find the area bounded in the first quadrant. So first step guys, graph natin yung curves. So this is y squared, therefore your vertex must face the y-axis. So it's either to the left or to the right. So x is positive, therefore this is facing right. So vertex is 0, 0. Facing to the right of x. So this is y squared is equal to 5x. So this will be x is equal to 1. You have here x is equal to 3. So those are vertical lines. So the area bounded is just in the first quadrant. So the total area bounded is actually in the first quadrant and in the fourth quadrant. But in this problem guys, we are just required to find the area in the first quadrant. So you must look into that. So we have decided to get a vertical rectangular strip. So same process guys. So area is length times width. So your length will be y minus y lower. So we have here the width differential of x. So area is the integral of length times width, that is y upper minus y lower, differential of x. From differential of x, therefore your limit must be in x-axis. So that is x sub 1. So here it is evident that x sub 1 is 1 and x sub 2 is 3. So in the board exam guys, after you have derived the elements, you just need to input it into your calculator. But in your undergrad, of course, you need the solution, the complete solution. So your y upper here actually touches the parabola. Therefore, your y upper is, you extract y, that is the square root of 5x. So, or y is equal to the square root of 5 times x raised to 1 half. And y lower actually touches y is equal to 0 there. So, it's evident in the curve. So, the bottom of your rectangular strip touches this point. So the point there is actually y is equal to 0. So that horizontal line is y is equal to 0. So your y lower is 0. So all the elements are there. Therefore, you just need to substitute. So you have here area is equal to the integral of, this is the definite integral. You have the limits from 1 to 3 of, you have here the square root of 5 x raised to 1 half minus 0. So the 0 is y lower, differential of x. So we simplify this. So constant, so we bring out, we have here the square root of 5 integral of x raised to 1 half, differential of x from 1 to 3. So this is power formula again guys. So square root of 5, here we have x raised to 1 half plus 1 all over 1 half plus 1 from 1 to 3. So we just simplify this. You have here 1 half plus 1, that is 3 halves. Square root of 5. So x raised to 3 halves all over 3 halves from 1 to 3. Further simplifying, we have 2 the square root of 5 all over 3. X raised to 3 halves. And last step is to input those limits. So area is equal to, so you have 2 the square root of 5 all over 3. So substitute your upper, subtract your lower to the upper. You have here 3 raised to 3 halves minus lower limit, that is 1 raised to 3 halves. Then we simplify this. So that is equal to 6.255. That is square units. So in this next problem guys, we have two parabolas here. Y is equal to, you have 6x minus x squared. And you have here y is equal to x squared minus 2x. So first step is to graph the curve. So we need to find the vertex, but it's evident here that it actually touches the origin. So if x is 0, y is 0. So we need to complete this square. So x squared minus 6x. It's either upward or downward. So we complete this square. So x squared minus 6x. So we add here 6 over 2 is squared or 3 squared. So that is 9. So if you recall our analytic geometry, so that is plus 9. Then you also add 9 to the other side to balance it. We have here x minus 3 quantity squared is equal to negative y minus 9. So we factor this out, negative 1. So h is 3 and k is 9. So that is our vertex there. So y is negative. Therefore, the graph is projected downward. So this is 6x minus x squared. So y is equal to 6x minus x squared. Then we graph the other parabola. So the other parabola also touches the origin. So if x is 0, y is also 0. So x squared minus 2x is equal to y. So we complete this square. So we just add 2 over 2 is squared or 1. So x squared minus 2x, we have here plus 1. We add 1 to both sides. So this is the quantity x minus 1 squared is equal to, you have y minus negative 1. So that is the form. Therefore, you can say here that your h is 1 and your k is negative 1. So the vertex is at 1, negative 1. Just plot those vertex. Y is positive, therefore it's projected upward. And this is our required area here. The area that is bounded by those two parabolas. So the rectangular strip can be horizontal or vertical, but the easiest way to solve this is to get a vertical rectangular strip. So it touches both curves. So this is y upper minus y lower. Your width will be differential of x. So same concept. Your differential of area is length times width. So a is equal to the integral of, this is the definite integral, y upper minus y lower, differential of x from x sub 1 to x sub 2. So x sub 1 is actually the intersection here, so that is 0. So what about x sub 2? So what is the other intersection or the boundaries? So we need to get that. So you need to equate those two equations in order to get the intersection. So x sub 1 equals 0, it's very evident. But what is the other value for x? What is the other intersection there? So you need to equate those two equations in order to get the common point. So it's a common point, it's an intersection. So if y is equal to 6x minus x squared, therefore 6x minus x squared is equal to also y on the other curve. So that is x squared minus 2x. So you have here 2x squared minus, you have 8x equals 0. And divide 2 to both sides, simplifying, we have x squared minus 4x equals 0. Then we factor out x, it's a common. So x times the quantity x minus 4 equals 0. So here, we have two roots. X is 0 and x is equal to 4. We have here x is 0. So x minus 4 equals 0. Therefore, x is equal to 4. So 4 is the other intersection. So x sub 2 is equal to 4. X sub 1 is 0. So this is 4. So we need to find what is upper y and what is lower y. So your lower limit is 0. 0 to 4. So what is y upper? Now y upper is the graph that touches the upper part of your strip. So it touches the curve y is equal to 6x minus x squared. So that is the projected downward curve. So that is 6x minus x squared. You have this equation. And the lower y, of course, the other parabola. The equation y is equal to x squared minus 2x. So the projected upward parabola. So y upper, that is 6x minus x squared minus lower y. So that is x squared minus 2x. So this is differential of x. So area is, we have this 6x minus x squared. So 6x minus x squared. So minus x squared, negative times negative, that is positive. So plus 2x. Then we simplify. So the definite integral of, we have here 8x minus 2x squared from 0 to 4. We have here differential of x. So use the calculator to solve this. You can use power formula, but the easiest way is to use your calculator. So equals, we have here 64 over 3. So that will be our final answer. So that is 64 over 3 square units. Centroid of an area by integration. So when you say centroid, it's also called the center of mass, or it is a point in your area in which it will balance. For example guys, meron tayo ditong square which is a regular shape. By inspection, we can say that the coordinates of the centroid, if this is in the Cartesian plane, you have here a over 2 and a over 2. So 1/2 lang nung length ng sides niya. So it's very obvious here that the center is, or the centroid is at a over 2 and a over 2. So what about if you're dealing with irregular shapes? That's the time when we need to use integral calculus. So as we recall, ang integral calculus guys, 'di ba? Kaya niyang i-solve yung area ng mga irregular shapes. And also it can solve the centroid of such irregular shapes. So guys, i-introduce ko muna sa inyo yung process of finding the centroid of irregular shape, but it can be divided into regular shapes. For example, here meron tayong T-shape wherein pwede natin siyang i-divide into two rectangles. So the total area will be A, the area of this T-shape. So let's say that the centroid will be at coordinates x bar and y bar. So you just multiply the area, okay? The area of the whole times the centroid of that total area. Now, we just divide this T-shape into regular shape. We have here two rectangles, so at the top and at the bottom. So let's say, so using these regular shapes, we can easily find its centroid. So if this is a rectangle here, say this is A1 and A2 at the bottom, meron siyang centroid guys. Let's say x sub 1 at the x-axis. So x muna tayo, x sub 1. And you have A2, it also has a centroid represented by x sub 2. Now the area times the centroid of the whole figure is actually equal to the sum of those regular shape times the centroid of those regular shapes. So i-add lang natin lahat guys. So a sub 1 x sub 1 plus a sub 2 x sub 2. This is the principle of finding the centroid. So for y, the same principle. So what about for irregular shape? So how can we solve problems involving the centroid of an irregular shape? So that's the time when we use integral. But basically guys, yung process natin is the same lang naman. Ito, ipapakita ko sa inyo kung paano siya i-derive yung formula natin. Meron tayong curve f of x na let's say ito yung kanyang centroid, x hat and y hat. So same process guys. So total area ng figure times yung kanyang centroid, x bar. So hahatiin lang din natin siya into rectangular strips hanggang sa kumpleto natin yung figure. So meron siyang mga rectangular strips. So let's say this is 1, 2, 3 and to several parts hanggang sa makumpleto siya. So basically infinite yung vertical strip natin. So as we recall, ang calculus guys is infinitesimal calculus. And when you are doing integral calculus, you are just adding up those infinitely small strips. That's why ginagamit natin siya when we are dealing with area. So parang i-divide lang natin yung area of an irregular shape, then ina-add natin siya using integral function. Now, let's say this strip is differential A. Yung differential A1 natin, say that this strip is differential A1, yung centroid niya is at x1, differential A2, x2, plus differential A3 times x3, and so on, hanggang sa makumpleto natin yung figure. Then, this summation, guys, inad natin lahat, diba? Inad natin siya lahat. Itong summation na to can be actually expressed the integral function or integral calculus. So, i-simplify natin na mawala na yung mga plus sign or yung summation, lalagyan na lang natin siya ng integral sign. So, the integral of, you have here, in general, yung mga single strip na yon is differential A times X. So, yun na guys yung formula natin. So, i-simplify lang natin. So, ang limit natin is x sub 1 to x sub 2 if you are dealing with vertical rectangular strip. Kasi kung ang dA natin is in terms of dx, of course, yung limit natin is differential of x. So, to simplify, sabihin natin na ang interval ng natin is from x sub 1 to x sub 2. So, therefore, yung centroid x bar is equal to, you have the integral of differential of a times x all over a. So, wag na natin muna lagyan ng limit because yung limit natin, guys, actually depends on your differential of area as we have discussed it before sa previous videos natin. So, balikan natin yung differential strip. So, doon naman tayo sa y-coordinate of our centroid, y bar. Now, as we recall, yung differential strip natin, guys, sa taas, nung length niya is tatama siya sa y upper. So, kung ito, guys, is a rectangular strip, therefore, yung coordinate ng centroid ng ating rectangular strip is actually the midpoint. So, yung nasa gitna, because this is just a rectangular strip. So, rectangle shape. So, yung midpoint niya is, we have here y upper plus y lower all over 2. So, we are just getting the average. Okay? So, we just change all those variables in our previous formula. The total area of the figure times y bar is equal to the integral of differential a times y. But y is y upper plus y lower all over 2. So, it is the midpoint. So, usually guys, hindi siya talaga naka-indicate sa mga reviewers. But here, linagay ko na in general kasi yon talaga yung kanyang basic concept. So, hindi siya na-mention in any reviewer. So, basta lang nilagay na y over 2. But here, it is y upper plus y lower all over 2. So, to further simplify, we have here y bar is just equal to the integral of differential of a times the quantity y upper plus y lower all over 2a. So, this is our formulas. So, na-derive natin guys yung mga formulas using simple and basic, yung mga fundamental concepts. So, balikan lang natin guys yung previous topic natin, which is yung area by integration. So, kung natin na yung area, so in most problem guys, usually dapat ang kinukuha natin is vertical rectangular strip. So, we have here differential of a. So, it's fine as long as tumama yung strip natin into both boundaries. So, you have here differential of a is length times width. So, rectangle siya, length times width. Yung length niya is y upper minus y lower. So, that is the distance of the length. Y upper minus y lower, and the width is differential of x. Then, to find a, we need to integrate both sides. So, yun na. Lahat ng elements is nandun na siya. You have here the limit. If you are dealing with differential of x, of course, your limit must be in x. If you're dealing with the horizontal rectangular strip, of course, you have here differential of y. So, your limit must be also in y. So, it's important. So, you have here, this problem is, we have a graph or curve y is equal to 0, x is equal to 0, f of x, and x is equal to 20. But f of x is just equal to, you have here y, or you have here equals x cubed plus 7x squared minus 5x plus 6. So we need to find the area bounded by this curve, and we need to find the centroid of that bounded area. So first step guys, of course, is to graph the curve. But in the board exam, no need na guys kung i-graph mo siya. Undergrad, you need to graph the curve para mas makita natin yung itsura or yung detail ng figure. So i-graph natin siya. Kunin natin guys yung kanyang curvature. So para makuha natin yung curvature, kukunin natin yung kanyang maxima and minima. So kunin natin yung y prime. So y prime equals power formula. You have here 3x squared plus 7 times 2, that is 14x minus 5 plus 0. Differential of constant is 0. Now we equate y prime to 0 to get the critical points. You have here 3x squared plus 14x minus 5 equals 0. So we can conclude here that we have two roots. So yung two roots na yun, those are the critical points. So you have here, the coefficient A is 3, B is 14, and C is negative 5. So we can use our quadratic formula. Or simplest step or simplest way to solve this is use your calculator, that is mode equation. Now just substitute all those variables. We have here negative b, that is 14, negative 14 plus or minus the square root of b squared minus 4ac. So a is 3 and c is negative 5. So 4 times 3 times negative 5. All over 2 times 3. So that is 6. Now just simplify this, or you can use your mode equation. So mode equation tayo guys. So mode equation, that is 5, and you have here quadratic, that is 3. Then we input the values. So for the coefficient of the variable, so we have here 3, 14, and negative 5. So equals lang. So equals, you have here yung first root natin guys is 1/3. That is x sub 1 is 1/3 and x sub 2 is negative 5. So we have two critical points. So kunin natin guys yung kanyang curvature. So what is the curvature? So what is the maxima and what is the relative minimum point? So kunin natin guys yung y double prime niya. So y prime equals 3x squared plus 14x minus 5. So let's solve for y double prime. So y double prime equals, we have here 6x plus 14. Then we substitute those critical points. So at x is 1/3, so you have a y double prime is equal to 6 times 1/3 plus 14. So this is positive. Okay? So it means that your graph here is concave upward. If you have concave upward, you have here a relative minimum. So 1/3 is a minimum. So what about negative 5? So we verify if it's a maximum. So 1/3 is a minimum, therefore negative 5 must be a maximum. So let's verify. So y double prime is 6 times. So input natin yung negative 5. We have here plus 14. So that will be negative 30 plus 14. So that will be negative 16. So therefore it is a negative. It means that it's concave downward. If it's concave downward, it means that it is a maximum. Therefore negative 5 is a maximum. So i-graph na natin yung curve. So i-determine na natin guys para ma-approximate natin yung graph niya. So 1/3 is a minimum, i-plot na lang natin yung points. So if x is 1/3, what is y? So balikan natin yung function. We have here. So in the board exam guys, no need na to graph this. So in your undergrad, actually you need the complete solution. So you need to graph the figure. And para mas maintindihan natin, kailangan talaga natin siyang i-graph. So i-input natin yung 1/3 dun sa function. So 1/3 approximately 5.15. So in the first quadrant. So at y is negative 5, you have here 81. So that is in the second quadrant. So negative 5, 81. And then the curvature at 1/3 here in the first quadrant is minimum. Therefore, it is concave upward. And at negative 5, you have here concave downward. So you have this graph. So this is the graph of the function. Then, i-graph natin yung x is equal to 20. Yung y equals 0, yung x-axis, yung x equals 0, yung vertical, which is the y-axis. Then, yung f of x, na-graph natin, and ang kulang na lang is yung x equals 20. So, somewhere here. So, vertical line siya. So, this is x equals 20. So, this is f of x. So, makita natin guys, ito yung area bounded sa first quadrant. So, ano yung intersection niya? So, yung intersection niya at x equals 20. So, that is 20, 10,706. Para mas ma-visualize natin. So, this is the graph. This is the area bounded in the first quadrant. So, we need to find the centroid of this area. You have here x bar and y bar. So, i-apply natin guys yung formula. So, x bar equals, you have here the integral of differential of a times x from x1 to x2. So, that is vertical rectangular strip all over a. You have the area natin is the integral of differential area. So, kunin natin guys yung differential area. So, kumuha tayo ng rectangular strip. So, that is a vertical rectangular strip. So, yung length ng rectangular strip natin is y upper minus y lower, and ang kanyang width is differential of x. And x sub 1 to x sub 2. So, we are sure here na ang limit natin guys is x sub 1 to x sub 2 because we have a differential x. Now, x upper will be f of x. So, it touches the f of x curve. So, y upper is f of x. Then, ang y lower natin actually touches the line y equals 0. So, yung y lower natin actually touches the line y equals 0. Yung x1 natin, yung limit natin, of course, this is from 0. So, from the graph, based on the graph, this is from 0 to 20. So, x sub 1 is 0, x sub 2 is 20. If your differential of a is equal to y upper, that is f of x, and y lower is 0, so you can say that f of x dx. So, area will be integral of, you have 0 to 20, that is our limit. And yung function of x natin guys is x cubed plus 7x squared minus 5x, you have here plus 6, differential of x. Then we use power formula. So area equals, so you have here x all over 4 plus 7x cubed all over 3 minus 5x squared all over 2 plus 6x. Ang limit natin is from 0 to 20. So, we just substitute the limit. So, gamitan natin guys ng calculator. So, in your calculator, you can actually input directly the integral. So, input lang natin yung integral. Yung equals you have here. That is 173,360 all over 3. So, that is our area. So, check na yung area. So, x bar will be, you have here differential of a. Differential of a is x cubed plus 7x squared minus 5x. So, that is f of x dx. Balikan ulit natin siya. So, that is x cubed plus 7x squared minus 5x plus 6. 5x plus 6. So, differential of x. Then, times x based on the formula. na na-derive natin kanina. So, times x all over area na nakuha natin, which is 173360. So, area, differential area is check na siya. Yung area is 173360 all over 3. So, x bar is equal to the definite integral of, so yung limit natin 0 to 20. So, i-multiply natin yung x, that is x raised to 4 plus, you have your 7x cubed minus 5x squared plus 6x, differential of x, all over yung area. So, the area is 173360 all over 3. So, integrate natin siya, guys. So, we have here x raised to 5, that is power formula, all over 5, plus we have here 7x raised to 4 all over 4 minus 5x cubed all over 3 plus 6x squared all over 2. So, from 0 to 20. So, this is all over 173360 all over 3. So, yan. Malapit na tayo sa katotohanan, guys. So, ito na yung answer natin. So, integrate na lang natin siya directly. So, in the board exam, guys, no need to solve this using the manual method. So, input lang natin yung integral. Actually, pwede mo na siyang i-input actually directly to your calculator as long as ready na lahat yung mga parameters natin. So, you have here 272,3,600. This is 2,723,600 all over 3. All over, you have here 173360 all over 3. I-simplify lang natin. That is the final answer. So here, our final answer is 15.71 units. So this is approximately 15.7. So that is our final answer. So the centroid, the x-coordinate of the centroid of that area is actually located at x equals 15.71. So we have here our next sample problem. So you have this equation or curve function of x, y is equal to 5 minus x squared. We have here x-axis. So we need to find the centroid of this figure bounded by this two curves. So x squared is equal to 5 minus y. So yung form niya is, so i-simplify natin, ilabas natin yung negative. So magiging siyang negative times the quantity y minus 5. So here we can say that the vertex is at 0 and 5. But y is negative, therefore this must be concave downward. You have here 0, 5. I-plot natin. Just plot the curve. 0, 5. This is the vertex. So, concave downward siya, guys. Because y is negative and x is squared. So, it must face the x-axis. So, our centroid must be located here. So, by inspection, guys, we can say that x is at 0. So, clear na yun na x is at 0 because if you solve differential of a times x, yung x natin, guys, is 0 lang naman siya based on this figure. So, nasa gitna na yung x natin. So, what about y bar? So, y bar, yung integral ng differential of a times y. From y1 to y2, if you are dealing with differential y, all over 2a. So, ito guys, y na lang linagay natin because yung nasa baba naman is 0. So, this is the midpoint, y over 2. So, integral of dA. So, yung area is the integral of differential area. So, ito guys, kung mapapansin natin, yung nasa baba ng graph is y is equal to 0. So, differential strip, this is y upper minus y lower times differential of x. Same process lang. Y upper minus y lower. Differential of x. So, ang limit natin guys, Since we are dealing with vertical rectangular strip, dun tayo sa x. So, x1 to x2. So, what is the limit? So, the limit is at y equals 0. So, just substitute in the parabola. What is the value for x if y is 0? So, at y equals 0, you have here 0 equals 5 minus x squared. Therefore, x squared is equal to 5. Then, you have x as plus or minus the square root of 5. So, this is the square root, so the value must be plus or minus. So, we have our limit, negative square root of 5 and square root of 5. So, y upper touches the parabola. So, the y upper is the parabola. So, area is the integral of, you have here 5 minus x squared. You have here, yung y lower natin guys, as I mentioned before, kung midpoint ng pagbabasehan natin, 0 lang naman siya. So, it touches y equals 0 sa baba. So, that is minus 0. Differential of x. So, this is the definite integral of 5 minus x squared dx from negative square root of 5 to square root of 5. So, i-distribute natin guys. Then, perform natin yung mga calculus formulas. So, this is 5x from negative 5 to the square root of 5 minus, you have here x cubed all over 3 from negative square root of 5 to positive the square root of 5. So, input natin sa calcu, we have here 14.907. So, i-store natin yun guys. Then, input na natin sa formula. So, lahat ng nakuha natin, input lang sa formula, then automatic, yun na, may answer na tayo. So, we just substitute all those elements. So, differential of A is 5 minus x squared dx. So, balikan lang natin yun because we need to substitute that into our formula. You have here y hat is equal to integral of definite. So, this is 5 minus x squared. So, differential of A is 5 minus x squared dx. But y is yung y upper natin. That is 5 minus x squared. So, actually, 5 minus x squared, y upper plus y lower all over 2. But yung y lower natin is 0 lang naman. So, yung limit natin is negative the square root of 5 to the square root of 5. All over 2a. So, 1/2 nung or yung midpoint niya. So, yung area natin, ni-store natin kanina, that is 14.907. Tinimes na natin para maging fraction siya, that is 40 square root of 5 all over 3. Then, i-perform natin yung nasa taas. So, i-simplify lang natin guys yung nasa taas, no? So, we have here the definite integral. So, y bar equals to, we have here limit natin is negative square root of 5 to the square root of 5. So, 5 minus x squared quantity, that is squared. So, differential of x. So, yung nasa taas guys, i-expand natin siya para ma-integrate natin siya. We have here 25 plus 10x squared. So, expand natin yung naka-square sa taas. That is plus x raised to 4. Differential of x. So, all over twice nung area, that is 40 the square root of 5 over 3. So, i-integrate natin. You have here 25x minus power formula 10x cubed all over 3 plus x raised to 5 all over 5. Then, we have this limit negative the square root of 5 to the square root of 5. So, yung limit natin guys, that is negative the square root of 5 to the square root of 5 all over yung twice ng area. So, i-simplify na lang natin guys. So, use natin yung calculator natin. So, using your calculator, yung sa taas natin will be 59.6285. So, i-substitute natin yung limit all over 40 the square root of 5 all over 3. So, yung answer niya is we have here 2. So, therefore, yung centroid natin guys, x bar and y bar, centroid coordinate is at 0, 2. So that will be our final answer. So next problem tayo guys. Practice lang ng practice na mag-solve ng problem. You have here x squared equals y and the line y is equal to x. So you have here guys yung next problem natin, that is x squared equals y and the line y is equal to x. So i-graph natin siya. So you have this area na bounded siya sa first quadrant here. So kunin natin yung strip that is vertical pa rin siya. So y upper minus y lower. Then yung width niya is differential of x. So this is 0, 0. Then yung intersection dun sa kabila is at y equals x. So equate lang natin guys yung y sa x. So x squared is equal to x, therefore x is equal to 1. So divide both sides by x. So this is at 1, 1. So differential of a is equal to length times width. We have here y upper. So yung y upper natin guys is yung line y is equal to x. Then yung y lower is yung y is equal to x squared. So differential of x. So this will be our differential area. So input natin yung formula. So this is the integral of dA times x from x1 to x2 all over. You have here yung total area. A. So let's find A. So A will be the definite integral of dA. So we have here x minus x squared differential of x from limit natin 0 to 1. We have here power formula. So x squared all over 2 minus x cubed all over 3 from 0 to 1. This is 1/2 minus 1/3. So input natin guys yung limit. So this will be 1/6. So 1/6 yung area. 1/6 is square units. So input lang natin sa formula. So that is x minus x squared dx times x all over area, that is 1/6. Then simplify natin guys. Makuha na natin yung x bar. So x bar equals, so yung definite integral, multiply natin yung x, that will be x squared minus x cubed dx from 0 to 1 all over 1/6. We have here 6, the integral of x squared minus x cubed from 0 to 1. So x bar equals, you have here 6 times x cubed all over 3, integrate natin, power formula, x raised to 4 all over 4 from 0 to 1. Then input the limit. So x bar equals 6 times, you have here 1/3 minus 1/4. So that is equal to, you have here 1/2 or 0.5. So x bar is 0.5. What about yung y hat natin? So y hat equals the integral of differential area times yung midpoint natin. So yung midpoint natin y all over 2. Yun. Yun ang midpoint natin guys, y all over 2. But yung area natin is 1/6. Nakuha na natin kanina. So y bar equals, you have here, so yung limit natin guys, kukunin natin siya sa x because yung area natin is with respect to x din, differential of x. So this is from 0 to 1. Ang y upper natin guys, that is x, and ang y lower natin is x squared. So kukunin natin yung midpoint niya. So y over 2 is equal to yung average niya or yung midpoint. So that will be x plus x squared all over 2. All over area na 1/6. So i-simplify lang natin guys. So you have here y bar equals, so the definite integral, that is x minus x squared times x plus x squared all over 1/3 na siya. So 1/3, so itaas natin yung 3, magiging times 3 siya. So 1/3. That is x minus x squared times the quantity x plus x squared differential of x. So y bar equals, so 3 times the definite integral of, so ito guys, so i-simplify natin. We have here x squared minus x raised to 4. So plus minus kasi yung sign niya. So pag in-expand, magiging x squared minus x raised to 4. We have here differential of x. So integrate natin guys, power formula. So this will become, so 3 times, you have here x cubed all over 3 minus, you have x raised to 5 all over 5. So limit natin is from 0 to 1. So substitute yung limit natin. So y bar equals, you have 3 times 1/3 minus, you have here 1/5. So that will become, so that is minus 3 times 0. So 0 lang yung lower limit. So yung y bar natin guys is equal to 0. This is 0.4. So therefore, yung coordinates ng centroid natin is at 0.5 and 0.4. So yung nakuha natin kanina, that is x equals 1/2 or 0.5. So this is our final answer. So 0.5, 0.4 is the coordinate of the centroid. So yung concept guys ng volume of integration is galing siya sa proposition ni Pappus. So si Pappus is a Greek mathematician. He was from Alexandria. Meron siyang dalawang proposition. So yung first muna natin i-discuss guys is yung pag-derive ng formula and ang kanyang concept. Then yung pangalawa natin gagawin guys is mag-solve tayo ng mga sample problem. So, yung first proposition ni Pappus guys is about the arc length and an area. So for example, meron tayong arc here, say S. Then yung arc natin is rotate natin siya about an axis. Let's say ito yung axis natin and yung distance ng arc to our axis, let's say R. So itong arc length guys is i-rotate natin siya about this axis. So i-rotate natin. So pag rotate natin yung arc length na S, so itong ma-form natin na area. So cylindrical siya but open yung top and bottom side. So area lang ang ma-form natin. So therefore, if you rotate an arc length about an axis, ang first proposition is that the area is equal to, of course you have this S, so this is R. So the area will be the length S times the circumference of that rotation, that is 2 pi R. So this is the first proposition. Now, the concept of volume in integration is based on the second proposition ni Pappus. So ano ba yung second proposition? So ito guys, itong arc length, gagawin lang natin siyang area. So let's say meron tayong rectangular strip, so vertical siya. So ito guys yung area. So yung area natin guys, i-rotate natin siya about an axis. So sabi sa second proposition of Pappus, if you rotate an area about an axis, you can form a volume. For example, ito i-rotate natin siya, makaka-form tayo ng hollow cylindrical shape. So ito yung rotate natin na rectangular strip. So rotate natin siya about a certain axis. So this will be R and this will be the area. Using the second proposition of Pappus, you can say that the volume is equal to area times yung circumference ng rotation natin. So this will be the basis of our formulas. So i-derive natin guys yung mga formula. So here guys, meron tayong vertical rectangular strip. So itong strip natin, of course, ang mga gamit pa rin natin guys yung mga diniscuss natin last time, which is the area by integration. So we have here, say ito y, and this is, you have here, differential x. Now, i-rotate natin siya about the y-axis. So let's try rotating this about the y-axis. So makaka-form tayo ng hollow cylindrical shape. So yung thickness niya guys is dx, as we can see here in the figure. So this is dx. This height will be y, and so this distance here will be x. So this is distance x, this is height y, and the strip thickness is differential x. Now, let's get the volume of this hollow cylindrical shape. So, pwede natin siyang guys i-cut sa gitna. So, makaka-form tayo ng parang rectangular prism. So, ganitong figure ma-form natin if we cut this hollow cylindrical shape sa gitna. So, ilalatag natin siya. this will be dx, this will be height y, and this will be the circumference. So, yung rotation niya. So, this will be 2 pi x. So, since this is a differential strip, so this is a representation. We have here differential of volume. So, that is equal to length times width times height. So, differential volume will be, we have here 2 pi x times y times dx. So, integrating both sides, guys, we can find the volume if we rotate this vertical rectangular strip about an axis. You have here differential volume, so that is equal to, you have here 2 pi x y differential of x. So integrating both sides, we have v equal, so integral of, so 2 pi, the integral of, we have here x y dx. Now, y is y upper minus y lower. So applicable pa rin, guys, yung mga concept natin in area. So we have here y as y upper minus y lower. So the one that touches the upper part of your rectangular strip and the lower part of your rectangular strip. So you have here volume equal, so 2 pi. You have here integral of x times y upper minus y lower differential of x. So ang limit natin, guys, is from x1 to x sub 2. So we have this formula. So this formula is applicable if ang rotation natin is vertical rectangular strip. Now, i-derive pa natin, guys, yung dalawa nating principle. So, doon tayo sa horizontal rectangular strip. So, sa horizontal rectangular strip, guys, meron tayong dalawang scenario. So, yung first case, i-discuss natin. So, this is dy, then this will be x. So, if you rotate natin siya about the x-axis, guys, so dikit siya sa x, na. So, i-rotate natin siya about the x-axis. So, maka-form tayo ng solid na cylinder. So, you have this differential y. So, this will be x. So, therefore, yung volume natin, so, differential volume is, so, area ng base, area, times yung height natin. So, differential volume equal, so, area of the base will be pi x squared. So, times height natin is differential of y. So, integrate natin both sides. V equals, you have here pi integral of, so, yung x natin, guys, of course, will be, this will be x right, and this will be x left. Ilagay natin, ha, x right minus x left squared differential of y. So, yung limit natin, guys, is y1 to y2. So, this is the first case. So, yung second case, guys, is yung strip natin is hindi siya nakadikit doon sa y-axis. So, meaning, so, yung ma-form natin, guys, if you rotate this, so, hindi na siya solid. So, magiging hollow cylinder na siya. Hollow cylindrical shape kasi hindi siya nakadikit doon sa y. So, meron siyang space. So, yung space na yun is ito na siya. So, if this is, you have this x left. So, ito, distance x left. So, this will be distance x right. Therefore, yung volume natin, guys, so same pa rin. You have this area of the base times yung height niya. So, yung height niya is dy pa rin. So, yung area ng base, guys, is the difference between the area of nitong big circle. So, this will be x right. So, yung malaking radius and yung maliit na radius. So, yung minus lang natin yung area nitong maliit because this is a space here sa area nitong malaking circle. So, we have here differential of volume equals, so, maging pi, you have here xr squared minus xl squared. So, i-factor out na natin yung pi times differential of y. So, integrating both sides, we have v equals, so, pi times integral of xr squared minus xl squared differential of y from y1 to y2. So, this will be our third principle. Ito, guys, yung gagamitin natin na formula is nakadepende siya doon sa ma-form natin na figure. So, importante na ipa-plot natin yung graph if it's really difficult to imagine the figure. So, importante na i-graph natin yung curves. So, yun ang first step of solving a problem. So, i-graph natin yung curves, then ititingnan natin kung ano or yung ano yung axis na kung saan siya i-rotate. So, importante yung figure in order for you to pick which formula of the three to be used. So, solve tayo ng sample problem. So, in this first problem, guys, we have here, what is the volume generated if the area bounded by the curve y squared is equal to 12x and the line x is equal to 4 is rotated about the line x is equal to 4. So, i-graph natin siya. So, first step is to graph the curve. So, yung graph natin, guys, is y squared is equal to 12x. Then, we have a line x is equal to 4. So, yung parabola y squared is equal to 12x. Yung vertex niya, guys, is nasa 0, 0. So, therefore, kung y squared siya, it's either left or right. So, positive yung x, it means na pupunta siya ng right. So, this will be y squared equals 12x. Then, yung line is equal to 4 is somewhere here. So, this is 4. So, this will be the line x is equal to 4. Sabi sa problem, is-rotate natin yung parabola, itong nasa bounded na area. So, ito. I-rotate natin siya about the line x is equal to 4. So, ang ma-form natin, guys, is parang football shape na volume. So, parang ganito yung ma-form natin na figure. So, mag-pick lang tayo, guys, kung anong strip yung kukunin natin. It's either vertical or horizontal. So, try natin, guys, i-solve siya using a horizontal strip. Then, naka-form tayo ng solid na cylinder. So, this distance is this. So, itong distance na to is, kung horizontal siya, this will be dy. So, this will be x. So, this will be x right. And this will be x left. So, this distance will be x right minus x left. Ito yung radius ng cylinder natin. So, ano ba yung x right? Ano yung x left? So, yung x right natin is of course yung tumama sa line, that will be 4. And yung x left natin, kunin natin yung x in terms of y. So, that will be yung x right is obvious siya na 4 kasi doon siya dumikit. Then, yung x left will be yung x ng parabola. So, that will be y squared all over 12. Then, ang na-form natin, guys, is solid cylinder. So, basically, yung volume natin will be the integral of, so you have here pi r squared times height. So, integral of, yung r natin is ito, xr minus x left. So, squared. Then, yung height natin will be differential of y. So, this is dy. So, ito yung gagamitin nating principle. So, volume is, you have here pi. So, the integral of, you have here xr minus x left squared differential of y. Now, kunin natin, guys, yung limits natin. So, yung limits natin sa y. So, therefore, ito. Then, ito. So, ano ba yung intersection natin, guys? So, what is the y coordinates if x is equal to 4? So, x is equal to 4 yung point na yon. So, 4. But, hindi natin alam yung y. So, i-substitute natin yung 4 dun sa parabola. So, this will be y squared equals 12x. So, y squared equals 12 times 4. You have here y equals, so the square root of, so this will be plus or minus, square root of 48. So, plus minus siya, guys, kasi square root. So, this will be negative, the square root of 48. This will be positive, the square root of 48. Therefore, ang limit natin, guys, is negative the square root of 48 to positive the square root of 48. So, volume equals, so pi integral of, so ang limit natin negative the square root of 48 to the square root of 48. Yung xr is 4, xl is y squared all over 12. So, this will be 4 minus y squared all over 12. So, this is squared differential of y. Now, i-expand natin to, guys. This will be your volume equals pi integral of, so, i-multiply na natin yung 12 sa 4. That will be 48 minus y squared over 12. So, pagsamahin na natin yung 4. So, you have your squared differential of y. So, negative the square root of 48 to the square root of 48. So, yung 12, so 12 squared, ilalabas na natin siya. So, volume equals, so pi, so 12 squared is 144. So, integral of I have here 48 minus y squared quantity squared differential of y. So this will be from negative the square root of 48 to the square root of 48. Now ito guys, i-expand natin para magamit natin yung power formula. But in the board exam, you can actually input this directly into your calculator. But here, pakita ko pa rin yung manual solving. So expand natin guys, we have here volume equals, so pi all over 144. So integral of, so that will be 48 squared minus, that is 96 y squared plus, you have here y raised to 4. So that will be differential of y. Then, pwede natin siyang i-integrate. So, you have here volume equals, so pi all over 144. So, this is 48 squared. This is y minus 96 y cubed all over 3 plus y raised to 5 all over 5. So, this will be from negative the square root of 48 to the square root of 48. So, yung limit natin. Perhaps, lagay na natin yung integral. So, this will be, so, pi, so, yung original, lagay natin. So, negative the square root of 48, have here square root of 48. So, that is 4 minus, so this will be 371.47. So yung volume natin guys will be 371.47. So this is cubic units. So next problem tayo guys. So yung formula ang gagamitin mo guys is depende siya sa figure. So hindi ka pwedeng basta-basta lang na kukuha ng formula. So nakadepende yan sa kung ano yung itsura ng ating figure. So you have this problem. Next problem tayo guys. Second problem, you have here given the area in the first quadrant bounded by x squared is equal to 8y. The line x minus 3 equals 0 and y-axis, what is the volume generated when the area is revolved about the line y minus 3 equals 0? So, i-graph natin yung curve. We have here x squared. So, it's either upward or downward. So, positive yung y. So, it means that ito ay upward. So, yung vertex niya guys, 0, 0. So, itong line is y minus 3 equals 0. So, y equals 3. So, this will be 3. Now, yung volume natin guys is revolve natin siya about the line y is equal to 3. So, ito yung rotation natin. Dito natin i-rotate sa line y minus 3. So, yung strip natin guys is, so this will be vertical. So, this is differential of x. So, this distance is y upper minus y lower. So, y upper natin, so minus y lower. So, yung y upper natin, of course, ito, y is equal to 3. Ang y lower natin is yung tumama sa parabola. So, this will be y is equal to x squared all over 8. So, i-rotate natin guys about the line y minus 3 equals 0. So, yung ma-form natin is, so, naka-upright na cylinder. So, this will be, so, this is dx. Therefore, yung radius niya is y upper minus y lower. Y upper will be at y equals 3. So, tumama siya dun sa, yun ang nasa taas. Tumama sa y is equal to 3. So, this will be 3 minus, yung y lower natin is tumama dun sa parabola. So, therefore, y equals x squared. So, sa parabola natin siya kukunin. Here, y is equal to x squared all over 8. So, yung na-form natin, guys, is solid pa rin siya na cylinder. So, you have here the volume will be, you have here pi r squared times height. You have here integral of, so, yung r natin is y upper minus y lower. So, this will be squared times thickness. Thickness is differential of x. So, yung limit natin is from x1 to x2. So, sinabi sa problem guys na only in the first quadrant. So, it means that dito lang tayo mag-start and ito yung boundaries natin. So, from 0, so x1 is 0. Then, x sub 2 will be this intersection. So, ano yung x doon? So, that is at y equals 3. So, i-substitute natin yung y na 3. So, x squared equals, we have here 8 times y is 3. So, this will be x equals, so, plus or minus the square root of, we have here 24. So, disregard na natin yung negative kasi yung negative is on the other side. We have here negative the square root of 24. But we are only required to find the area in the first quadrant. So, ito lang. So, yung mabubuo natin figure guys, kung itong bubasayan natin is something like this. So, yung x sub 2 natin is the square root of 24. So, that is positive. So, nandun na lahat yung elements guys. Substitute na lang natin and integrate and apply the limits. If your volume equals, so sa board exam guys, directly input na lang sa calculator if nakuha na natin yung expression of the integral. So this will be volume equals, so pi integral of to y upper minus y lower. So this will be 3 minus x squared all over 8. So this is squared. Then we have here differential of x. Then yung limit natin from 0 to the square root of 24. So ito guys, pag nakuha natin to, automatic sa calcu. But here, solve pa rin natin siya. So ito expand natin. So volume equals, so pi. Then i-multiply na natin sa 8 yun. So 24 minus x squared all over 8. So this will be squared, differential of x. Now yung 8 squared, so 8 squared siya. Ilipat na natin sa labas. So, volume equals, so pi all over 64. The integral of, so, ito expand natin siya guys. So, 24 squared minus twice. So, 24 plus 24, so 48x squared. Plus, so, negative x squared times negative x squared. So, positive x raised to 4. Differential of x. So, yung limit natin is from 0 to square root of 24. So we have here volume equals, so pi all over 64. So this will be, you have here 24 squared, so x minus 48x cubed all over 3 plus x raised to 5 all over 5. So yung limit natin is from 0 to the square root of 24. Yung lower limit is just 0, so is transfer lang natin or substitute yung upper limit. Ito guys, after ma-input sa calcu, so pwede mong gamitin yung calc. So you have here the square root of 24. So ang answer natin guys is 73.87 cubic units. Sa board exam guys, itong process is na-omit na siya because you can use your calculator to solve this integral. So you have this integral of, so pi limit 0 to square root of 24. You have here 3 minus, you have here alpha x squared all over 8. So quantity squared. So yun, input lang natin, then automatic answer siya, 73.87 cubic units. So last problem na tayo guys. So ang technique natin guys is practice lang ng solving. So as much as you practice, ma-master mo yung topic kasi without repetition guys, wala tayong retention. So it's better kahit na nasolve mo na yung problem, pwede mo siyang ulit-ulitin kahit mga 5 beses pa hanggang sa ma-master mo siya. So importante yung repetition guys. That's why in the review sa board exam, talagang you need to solve more problem kaysa dun sa expected mo na kaya mong isolve. So you must go beyond your limits. So try tayo mag-solve guys ng next problem. So the area bounded by the curves x squared is equal to y, and yung line is x is equal to 5, and the x-axis in the first quadrant is revolved about the y-axis. So what is the volume generated? So graph natin yung curves. We have here x squared is equal to y. So ito ay upward siya guys because y is positive. So this is x squared equals y. Then yung line natin is x is equal to 5. So this will be our, say this is 5. So ito yung line natin. Now, ang rotation natin guys is about the y-axis. So dito natin siya i-rotate. So kuha tayo ng strip natatama siya sa line and sa parabola. So, there's only one way to do that, but to have a horizontal rectangular strip. So, this will be differential of y, and this is, so ito guys, kung i-rotate natin siya about the y-axis, ang ma-form natin guys is of course, may space siya dito. So, ang ma-form natin is hollow cylindrical shape. So, ito yung ma-form natin. Dito na magbabase yung kung ano yung formulang gagamitin natin. So, itong point na to, so this point is actually your x left. So, this is x left distance. Then, this point will be your x right. So, ito yung na-form natin na figure guys. Yung height natin here will be differential of y. So, in-exaggerate ko lang yung figure. So, basically, ito yung strip natin here. So, yung formulang gagamitin natin is volume equal. So, you have your pi integral of, you have here x right squared minus x left squared. You have here differential of y from y1 to y2. So, hanapin natin lahat yon. So, from this figure, we can say that x left, this is x left, so this is x right. So, x left will be your parabola. So, basically, you have here x squared is equal to y. So, kunin natin yung x in terms of y. So, x equals, so the square root of y. Then, yung limit natin guys is, so we have here dy. So, meaning, so that is from this point. Ano ang coordinates y nito and yung coordinate y nito. So, from this, you can say that this is 0. Of course, 0 siya. So, 0. So, this is 5, 0. Then, this point will be, you have here 5. So, 5 squared. So, meaning this is 25. So, substitute lang natin yung 5 dito. So, we have here 25. So, 5, 25. Meaning, yung limit natin is from 0 to 25. So, volume equals pi integral of. So, 0 to 25. So, xr. So, x right natin guys is ito. So, x right will be x equals 5. So, tumama siya dun sa line x is equal to 5. So, this will be 5 squared. Minus yung x left. X left is the parabola. So, the square root of y. So, this is squared. You have here differential of y. So, volume will be, so pi, from 0 to 25, you have here 25 minus, we have here y. So, differential of y. So, integrate natin, we have here v equals, so pi, so 25, so this will be y, minus y squared all over 2. So, this is from 0 to 25. Then, calculate natin guys. So, this will be 625 pi all over 2. Or, we have here 981.75. So, volume is 981.75 cubic units. So, ito guys, yun ang final answer natin. But in the board exam, kung nakuha mo na to guys, you just need to input nung integral natin. So, yun guys. So, same lang siya. So, mas madali if you are going to use your calculator, but this will be only applicable sa board examination. So, undergrad, you need the complete solution. So, that's it guys. I hope that you have learned from this video. Ang advice ko guys is practice lang ng practice mag-solve ng problem. Kasi ito, you might think this as difficult at first, pero habang na-practice nyo siya, mas nagiging madali sa inyo ang pag-solve. So, yung sinabi ko kanina, I repeat, even if na-solve mo na yung problem, alam mo na siyang i-solve, hindi masama yung pag-ulit ng mga problem. So, practice lang mag-solve because retention is important in the board exam. So, kasi if you have no retention, of course, syempre, makakalimutan mo yung mga formula. So in order for you to have the retention of the topics na pinag-aaralan, you need to solve as much problem as you have to. So, mag-solve ka ng problem na beyond doon sa limit mo. So, practice lang ang sikreto guys. Tandaan lang natin na yung mga formulas, na tatlong formula na ginagamit natin is nakadepende naman siya sa kung ano yung itsura ng figure. So, here, important na alam natin yung concept of area because it do so much of this concept. Meaning, yung foundation of this concept will be, yung, of course, yung mga basic or fundamental integration formulas, and of course yung area natin, yung previous topic. So i-master natin guys yung area para maging madali lang sa atin yung pag-solve ng mga volume like these problems. Centroid of volume by integration. So if you recall guys, yung topic natin na previous nung volume by integration is all about yung centroid of an area by integration. So yung formulas natin guys is the same lang naman siya when it comes to the centroid of the volume. In this case guys, palitan lang natin ng volume yung area. So volume times x bar equals, you have here the integral of dv times, you have here x. So papalitan lang natin yung differential area ng differential of volume and then yung area with volume. So therefore, you have this formula x bar equals, you have the integral of differential of volume times x all over volume. So ito yung formula natin for yung centroid natin sa x-axis. Now, when it comes to y-axis, so yung y bar is equal to, so yung integral of differential of volume times yung midpoint natin y all over 2 all over yung volume. So ito guys, yung y all over 2 is yung midpoint. So itong dalawang formula guys is applicable siya if yung strip natin, which is the rectangular strip, is vertical. So if you have this vertical, so ito yung axis natin. So this distance will be x. But this distance, yung kalahati, will be yung midpoint. So y all over 2. If it happens na yung strip natin guys is horizontal, so meron tayong horizontal strip. So yung distance ng centroid ng horizontal strip in terms of x-axis will be reverse na. So x all over 2 kasi yung distance nito is x. So yung midpoint nito is x all over 2. Then yung y natin will just remain to be y. So yun ang pagkakaiba guys. So depende siya sa ginamit natin na rectangular strips. So in this first problem guys, we have find the centroid of the solid formed if the area in the first quadrant of the curve y squared equals 4x, the y-axis and the line y minus 6 equals 0 is revolved about the line y minus 6 equals 0. So you have this y-axis. So ito yung parabola natin. This is your y-axis and you have the line y minus 6 equals 0. So i-graph natin yung curve guys. So you have here y squared, so it's either to the left or to the right kasi dapat yung vertex niya nakaharap sa y-axis kasi y yung naka-squared. Then positive yung x, it means that this is a curve that is concaving to the right. So yung vertex natin guys is 0, 0. So this is y squared equals 4x. This is line y minus 6 equals 0. So i-revolve natin yung area bounded in the first quadrant. So ito yung area bounded in the first quadrant. So itong area is i-revolve natin about the line y minus 6 equals 0. So yung ma-form natin guys na figure is like a cone. Cone siya. So i-revolve natin parang magiging cone siya. So yun. So yun ang ma-form natin na volume. So here guys, it's very obvious na the centroid of your volume, ito yung volume natin, yung parang cone, kasi i-revolve natin yung area about the line y minus 6. It's very obvious here that yung centroid natin sa y-axis will be located at y minus 6 kasi siya yung nasa gitna na. So, yung y natin, y bar, automatic siya ay equal 6. Because dumaan yung centroid, of course, sa gitna nitong figure. But what is the coordinates of x bar? So, yung y bar natin is itong distance. So, this distance will be 6. But yung x bar here is hindi pa natin yun na-solve. So, solve natin siya using ng formulas natin. So, yung strip natin guys, kuha tayo ng vertical rectangular strip. So, dito siya kukunin. So, here. Then, ito, i-rotate natin about y minus 6 equals 0. So, yung ma-form natin na figure is a disc-shaped figure. So, solid na cylinder. So, you have this. Ito ay differential of x. Itong distance will be y upper minus y lower. So, this is thickness differential of x. Now, yung y upper natin is located here. So, y equals 6. So, y minus 6 equals 0. So, y is equal to 6. So, y upper equals 6. And y lower will be y in terms of x of the parabola, since it touches at y lower in the parabola. We have here the square root of, so y here will be the square root of 4x. Or, we have 2 the square root of x. So, this will be our y lower. So, apply natin yung formula. You have here x bar will be equal to, you have the integral of differential volume times x all over volume. Now, let's find what is the volume. You have here differential of volume will become, we have area of the base times height. So, that is pi. So, radius natin is y upper minus y lower. So, that is squared. And thickness is differential of x based on this na na-generate natin about revolving yung rectangular strip. So, naka-form tayo ng solid cylinder. So, yung volume niya is area ng base times height or thickness na x. So, integrating both sides, we have volume equals, so integral of pi y upper minus y lower squared differential of x. So, yung pi ilabas natin because it's a constant. So, v equals, so pi integral nun. Then, yung y upper natin is 6. You have here volume equals, so pi integral of, so you have 6 minus y lower is 2 the square root of x. Or, simplify na natin to guys, x raised to 1/2. So, this will be squared differential of x. Now, ano yung limits natin? So, yung limit natin is located at the x-axis because we have here differential of x. So, yung limit will be the x-axis. First quadrant lang tayo guys. So, that is from 0. Okay? It's evident here na 0 yung boundary. So, 0 to this point. So, ano yung point dito? So, at y equals 6. So, substitute natin yung 6 doon sa parabola. So, you have here y squared. Your 6 squared equals, you have here 4x. Therefore, this is 36 equals, so 4x. Therefore, x equals, so 36 divided by 4. So, that is 9. So, 0 to 9 yung limit natin. So, this is 0x. This is 9. So, this will be 0 to 9. So, differential volume here. So, ito siya. Then, volume, itong masolve natin here. So, volume equals, so ito guys, i-input na natin sa calculus. So, yung process is of course, expand natin, then power formula. But this time, use na natin yung calculator. So, integral of, have here pi, 0 to 9. You have here 6 minus, so 2 alpha x raised to 1/2 squared. So, we have here equals, so yung volume natin guys, that is equal to 169.646. So, then proceed na tayo dun sa centroid. So, this is equal to, you have the integral of, so limit 0 to 9. So, dv is this. So, pi, yung pi ilabas na natin. So, this will be pi times, you have here 6 minus, you have 2x raised to 1/2. So, this is squared. So, dx, then times tong x. So, all over volume, which is 169.646. So, automatic, masolve natin yung x bar. So, x bar will be, so input, calcu na lang. You have here times. So, dagdagan lang natin yung differential volume ng times x. So, multiply tayo ng x. Then, equals ulit. So, ito na yung integral ng itong expression. Now, i-divide natin siya sa 169. So, divide 169.646. So, that will be 1.8. So, x bar is 1.8. So, balikan natin yung figure. So, this centroid here will be at 1.8 and you have here 6. So, this is our final answer. So, that is letter B, 1.8 and 6. So in this next problem, guys, we have find the centroid of the solid form if the area in the first quadrant of the curve y is equal to x raised to 4, the y-axis and the line y minus 16 equals 0 is revolve about the y-axis. So i-graph natin yung curve, guys. So parang parabola siya. So this is y is equal to x raised to 4. Then you have this line. This will be y is equal to 16. So this point will be 0, 16. Then based on the problem, yung area in the first quadrant, which is ito, i-revolve natin siya about the y-axis. So ito yung ma-form natin solid. So parang ganito. So we need to find the centroid of this solid. So somewhere here. Let's say here. So this is x bar and y bar. So here, guys, it's very obvious na ang x bar natin is at 0. So dito siya dadaan. But yung y bar natin is missing. So let's solve for y bar. So pili muna tayo ng rectangular strip. So since na-rotate natin siya dito, guys, sa y-axis, ang rectangular strip natin is we have this horizontal. So we have this x right minus x left, yung distance, and you have this differential of y. Now, here, hindi natin i-divide sa 2 yung distance ng y natin sa strip. Because yung rectangular strip natin is horizontal. So basically here, this is just y. So walang divide by 2. So may divide by 2 if you have this vertical rectangular strip. But in this case, horizontal siya. It means that hindi natin siya i-divide sa 2. Wala tayong midpoint na kukunin. So kung x naman, dun makukunin yung midpoint because here, this is 1/2. So yung centroid natin, y bar is equal to, so integral of dv times y. So walang over 2. All over this volume. So itong volume na generate natin. Yung strip natin, guys, is horizontal. So itong ma-form natin. So disc shape. Then yung thickness natin is differential y. Then you have this radius. Yung radius niya is x right minus x left. So x right will be this point. So itong point na to tumama sa parabola. Therefore, x right will be y raised to 1/4. So x equals y raised to 1/4. So x left is somewhere here. So it means that is line x equals 0. 0 lang yung x left natin. So kunin natin yung volume. So you have here v that is equal to the integral of, we have pi, we have x right minus x left squared, differential of y. So this is from y1 to y2. So yung limit natin, guys, makuha natin dun sa graph. So this is, so ilabas na natin yung pi. So pi integral of, so x right will be, you have y raised to 1/4. So minus 0. So 0 siya. So this is squared, differential of y. So may minus 0 kasi yung x left natin is 0. Now yung limit natin, tingnan natin yung graph. So sa y tayo, first quadrant lang. Meaning this is from 0 to, so this is 0, 0. So if this is 0, 16, therefore 0 to 16. You have here v equals, so pi times integral of, so 0 to 16. Y raised to 1/4 squared, so that is y raised to 1/2. So differential of y. You have here equals, so power formula, guys, you have pi, you have y raised to, so 1/2 plus 1, that is 3/2, all over 3/2 from 0 to 16. So volume equals, so pi, so y natin, that is 16 raised to 3/2 all over 3/2. So this is 128 pi all over 3. So this is our volume. So balikan natin, guys. So y bar is equal to, we have here integral of differential volume times y all over v. So wala na tayong all over to sa y, guys. I repeat kasi yung strip natin is horizontal siya. So input natin lahat. So we have here y bar is equal to, so integral of, so 0 to 16. You have here pi, so dv. So dv is ito, which is ito. And na-simplify natin, which is y raised to 1/2. Y raised to 1/2, we have here differential of y times ito, y. So, ito guys, ito yung dV natin. And ito yung y. So, all over volume, which is 128 pi all over 3. So, you have this integral of, so 0 to 16. So, pi, ilabas natin. So, you have here y raised to 1 half times y. So, y raised to 3 halves. Differential of y. All over 128 pi all over, you have here 3. So, input na natin guys sa calcu. So, sa board exam, so, ito lang i-input natin. So, automatic, masolve na yan ng calculator. So, here, kung manual solving, so, of course, gagamitin mo pa rin yung power formula. All over yung volume natin, which is 128 pi all over 3. So, equals lang. Input na natin lahat. So, y bar is approximately equal to 9.6. So, we have here 9.6. So, therefore, yung centroid ng volume natin, which is the curve y is equal to x raised to 4, then yung y is equal to 16 bounded sa first quadrant, rotated about y-axis, is at, you have here, this is 0 and 9.6. So, that is letter A, guys. So, I hope that you have learned from this topic. So, practice nyo lang guys yung pag-solve because mamamaster nyo din to. I know. As long as you solve more problems. So, solve natin lahat yung mga scenarios of the problem para at least prepared tayo once na or if na lumabas man to sa board exam. So, yung moment of inertia guys is needed in our mechanics of materials or yung ating strength of materials. So, the best way to imagine what moment of inertia is that it is the measure of the beam's ability to resist bending. So, it means that if you are comparing whether a material will bend less or bend more compared to other materials, we'll just solve for their moment of inertia. So, since yung moment of inertia is actually the ability of the material to resist bending, it is always positive. So, kung i-compare mo guys yung dalawang object, if an object, say object 1 and object 2, if this is an object with high moment of inertia compared to this which has a low moment of inertia, it means that this material with lower moment of inertia I, so I ang ating variable, will actually bend more. Kasi mas mababa yung kanyang moment of inertia ng kanyang area. And when you're dealing with an object with a higher moment of inertia compared to other objects, this object will actually bend less. Then, ang moment of inertia natin guys, is hindi naman siya constant. Nakadepende siya sa axis. So, with respect to the axis or nakadepende siya guys sa orientation. So, for example, meron tayo ditong stick. So, meron siyang area. So, meron siyang centroid of course. If you can imagine this, i-bend natin siya with respect sa centroid niya. Madali siyang mabali compared if you bend it somewhere here. So, i-bend natin dito. Imagine yung stick siya. If you bend it here, somewhere here, hindi siya centroid, it means that hindi siya mag-bend easily. So, the moment of inertia in the centroid is actually the least. Ito yung moment of inertia sa centroid natin. Let's say CX and CY, ICY. So, yung moment of inertia that passes through the centroid is actually the least. Ito yung least moment of inertia ng area natin. Compared if ilalayo natin siya doon sa centroid niya. Moment of inertia, meron siyang IC, X, and ICY, meaning with respect to the X or Y axis. Pero guys, hindi ito component. So, huwag kayong ma-confuse, hiwalay siya, hindi siya ina-add. So, let's go guys to the computational method. So, yung moment of inertia guys, meron siyang similarity doon sa centroid. Yung centroid guys, di ba, X bar is equal to integral of, you have here X dA all over A. So, itong expression guys, this is what you call the first moment of area. Now, when you're dealing with moment of inertia, ang tawag sa moment of inertia is the second moment of area. Now, yung moment of inertia with respect to x. So, kung with respect to x tayo guys, yung strip na kukunin natin is actually horizontal siya. So, this will be differential y. This will be x right minus x left. So, the moment of inertia with respect to x. So, kung with respect to x tayo, yung distance ng area, which is the differential strip, differential area, so yung distance ng strip natin, which is a horizontal strip, with respect to the x-axis, will be at distance y. Therefore, this will become integral of, so first moment of area, that is y dA. So yung first moment, guys, is i-multiply lang natin siya sa moment arm, which is the distance from the strip with respect to the x-axis, which is y. That's why, tinatawag natin, guys, yung moment of inertia as the second moment of area. Because meron siyang connection dito sa centroid natin. So, this will become, so Ix equals, so y squared differential a. So, that is the integral. So, ito yung formula natin with respect to x. So, if with respect to y tayo, yung formula magiging, so with respect to y, this will become integral of, so x squared differential a. So, yung differential a, na-discuss na natin yan sa area by integration. So, meron tayo ditong dalawang formula. So, magkaiba siya, guys, no? Mapapansin natin because we are dealing here with the distance of the strip to the reference axis. So, first problem tayo, guys. What is the moment of inertia of the area in the first quadrant bounded by the curves y squared is equal to 4x, the x-axis, and the line x is equal to 1 with respect to the x-axis. So, first step tayo, guys, i-graph natin yung curves. So, ito, guys, first quadrant lang tayo. Then, yung y squared is equal to 4x. This is projected to the right. So, this is y squared equals 4x. Then, yung line natin, x is equal to 1 somewhere here. So, this is 1. So, this is our line. Now, concerned lang tayo, guys, dito sa area in the first quadrant. So, hinahanap natin is Ix with respect to x tayo. Therefore, yung strip natin will be horizontal. So, this will be, thickness niya is differential y kasi projected sa y-axis. Then, yung length niya will be x right minus x left. Therefore, yung differential area will be, you have length times width na dy. So, that will be xr minus x left differential of y. Now, i-apply natin yung formula. So, Ix is equal to the integral of, you have y squared differential a. Then, i-apply natin siya, guys. So, you have here Ix is equal to, you have here integral of y squared. So, yung xr natin, guys, dito, so differential a, mag-substitute tayo. So, xr minus x left differential of y. So, yung xr natin is x right. So, x right will be this graph. So, x equals 1. Y squared. So, x right is 1 minus yung x left natin is tumama sa parabola. So, that will be x equals, so y squared all over 4. So, x in terms of y tayo. So, this will be y squared all over 4. So, differential of y. Now, yung limit natin. So, first quadrant lang, guys. Yung limit natin, of course, here. This is 0, 0. Then, from this point, at x equals 1. So, yung 1 substitute sa parabola. So, y squared equals, so 4 times 1. So, y equals, so square root, so plus or minus 2. Means ito, of course, negative 2. Then, yung taas, that is 2. So, 2 ito. 2 yung coordinate y natin. So, first quadrant lang tayo. If it happens na kung buo yung hinahanap, of course, magsisimula ka, limit mo, negative 2 to 2. But since in this problem, hinahanap lang natin, guys, is in the first quadrant. So, that is from 0 to 2. So, just substitute the limits, then perform the integration. You have here Ix, that is equal to, you have the integral. So, ang limit natin, 0 to 2. So, y squared minus y raised to 4 all over 4. So, differential of y. So, equals. So, perform natin yung power formula. So, this will become y cubed all over 3 minus y raised to 5 all over 5 times yung denominator na 4. So, from 0 to 2. So, this will just become, so y cubed all over 3 minus y raised to 5 all over 20 from 0 to 2. So, ito, substitute natin yung 2. So, that is 16 over 15. Yung Ix natin, guys, 16 over 15. So, ano ba yun sa decimal? So, that is 1.067. So, yung answer natin, guys, is letter B. Now, meron tayo, guys, na alternate solution for this. If you're dealing with shapes na ito, regular shape to or common figure, meron tayong mga ready-made formula. So, I advise for you to memorize those table. Meron tayong table sa mga various reviewers of those moment of inertia as well as centroids. So, if you're dealing with parabolic segment siya. So, ang formula natin, guys, the moment of inertia with respect to x will become 2 over 15. So ito guys, na-derive lang naman siya using integral calculus, that is hb cubed. But if you're dealing with moment of inertia with respect to y, that is 2/7 bh cubed. This is for parabolic segment. So you must look into the table guys. Meron tayong table which actually gives the centroid area as well as moment of inertia of the area. Now, ano ba yung h and b? So, meron tayo dito, parabolic segment. So, yung figure kasi natin is half lang siya ng parabolic segment kasi first quadrant. So, if this is the vertex, this will be our h and this will be our b. So, kunin lang natin yung mga lengths na yon, then automatic apply sa formula. So, ix equals, so 2 over 15, ano ba yung h natin? So, let's go back to the figure. So, yung h natin is ito. This will be distance 1. So, this is x is equal to 1. So, therefore, this is 1 unit. Then, this height here will be, of course, that is 2. So, h is 1. Then, b is 2. So, this is 1 times 2. So, cubed. So, ix will become, so this is 2 times 2 cubed. So, 8. So, 2 times 8, that is 16 over 15. So, same answer lang, guys. So, 1.067. Yung next problem natin guys, find the moment of inertia of the area bounded by y equals 0, f of x equals 0, and x equals 20. So, yung f of x is equal to x cubed plus 7x squared minus 5x plus 6. So, with respect to the y-axis. So, i-graph natin yung curves. So, kung familiar na kayo guys, sa mga problems na silob natin last time, so, yung f of x natin here, x cubed plus 7x squared minus 5x plus 6. So, ang graph niya is something like this. So, this will be at, say, x equals 20. So, this will be our f of x. So, kung paano gawin to guys, go back to our previous discussion. So, ginamitan ko siya ng maxima and minima. Then, yung area natin guys, ito, in the first quadrant. So, guys, ang hinarap natin dito is with respect to y-axis. Yung strip natin, of course, will become vertical. Ito yung strip. So, this will be differential x. Then, you have here y upper minus y lower. So, y, moment of inertia with respect to y will become the integral of, so yung distance natin from your strip to the y-axis will be x. So, this will be x squared differential of area. Then, yung differential area natin, ito. Differential area is length times width. So, y upper. So, y upper will be the curve f of x. So, yung f of x natin is, so that is x cubed plus 7x squared minus 5x plus 6. So, this is y upper, x cubed plus 7x squared minus 5x plus 6. Y lower natin is, of course, y equals 0. So, 0 siya. Ito yung boundary. From y lower to y upper. To thickness, differential x. So, substitute lang natin guys. Then, yung limit natin is differential x tayo. So, x-axis. So, from 0 to 0, 0. So, this will become 20, 0. So, therefore, yung limit natin is from 0 to 20. So, we have here, iy will become, so that is integral of x squared, differential area. So, differential area, substitute lang natin. So, x cubed plus 7x squared minus 5x plus 6, differential of x. So, yung limit is from 0 to 20. Then, simplify, integrate, substitute the limit. So, here, iy will become, so, substitute natin, simplify natin. So, x raised to 5 plus, you have here 7, x raised to 4 minus 5x cubed plus 6x squared. So, this is differential of x. So, this will become the integral. So, 0 to 20. So, iy is equal to, we have here, x raised to 6 all over 6 plus 7x raised to 5 all over 5 minus 5x raised to 4 all over 4 plus 6x cubed all over 3. That is from 0 to 20. Substitute yung 20. So, iy equal. So, yung lower limit 0. So, no need to subtract yung lower limit. So, 20 raised to 6 all over 6 plus, you have 7 times 20 raised to 5 all over 5 minus 5 times 20 raised to 4 all over 4 plus, you have here 6 over 3, so 2 times 20 cubed. So, IY, approximately 1.5. So, this is 1.5 times 10 raised to, so 7 siya. So, ito yung final answer natin, guys. So, that's it. So, practicean nyo lang, guys. Magiging madali sa inyo if you practice solving more problems. So, in my next topic, I will be discussing yung last topic natin, guys, that is work by integration. Hi, guys. So, in this video, ang topic natin is work by integration. So, the concept of work is that work is equal to force times distance. So, this will be our concept for this topic. So, the first application of work that we are going to discuss is the work done by a spring. So, yung spring natin, meron siyang original length, say L. Then, if you apply a force on that spring tension, it will elongate for a distance x. Now, work is equal to force times distance. Well, in terms of derivative, we can say that differential of work is equal to force differential of distance. Let's say differential of x. So, in terms of derivative. So, in springs, we have a concept, what we call the spring constant, K. So, the spring constant K is actually the force per unit of elongation. So, if you apply a force, it will elongate at a certain distance x. So, therefore, F is equal to Kx. Then, we substitute it here. So, differential work is equal to, you have force that is Kx dx. Then, K is a constant. So, integrating both sides, we have work equal. So, K integral of x dx from yung elongation natin, x1 to x2. Then, yung elongation natin, which is the x1 and x2, ang reference point niya, of course, is yung original length. So, we have here work is equal to, you have K, power formula, that is x squared all over 2 from x1 to x2. So, this will be our formula in a work done by a spring. So, let's apply this formula. So, find the work done in stretching a spring of a natural length of 10 cm from 12 cm to 15 cm. 8 newtons is needed to hold it at a length of 12 cm. So, the length of the spring, that is the original length, is 10 cm. So, x1 natin, that is the initial elongation, will be, that is from 12 to 15 cm. So, if you have 10 as your reference point, if the elongation is 12 cm, therefore the change in distance is 2 cm. So, x1 is, we have here 12 cm minus 10 cm. So, that is 2 centimeters. Then, the final elongation, x sub 2. X sub 2 will be a total length of 15 cm. Therefore, the change in elongation will be 15 cm minus the reference length will be the 10 centimeters. So, x sub 2 will be, you have 5 cm. So, this will be our limits. Now, assume a force of 8 newtons is needed to hold it at a length of 12 cm. Therefore, yung K natin is force over the elongation. So, assume a force of 8 newtons is needed to hold it at a length of 12 cm. So, if our reference length is 10 cm, so the total length is 12 cm. Therefore, the elongation is, you have here 12 cm minus 10 centimeters. So, K will be, you have 8 newtons all over. So, this is 2 cm. So, that is 4 newtons per cm. So, i-apply natin yung formula. Na-derive natin lately. We have here work equals. So, that is 1/2 K. So, x sub 2 squared minus x sub 1 squared. So, i-apply na natin yung limits. So, we have here 1/2 K. So, K is, so 4. So, x sub 2 will be 5. So, 5 squared minus x sub 1, that is 2 squared. So, work is, we have here 2 times, so 25 minus, that is 4. So 21 times 2, so that is 42. So unit, so Newton per cm, so this will become Newton cm, kasi this is squared, so Newton cm times cm squared, so Newton cm. But our unit in our choices is joule, so we need to convert this to Newton meter, so that is equivalent to joule. So work equals, so 42 Newton cm, so multiply to our conversion, so that will become, so 1 meter, so that is 100 centimeters. So cancel yung centimeter, you have 42 divided by 100, so that is 0.42 joule or Newton meter. So joule na siya, so 0.42 joule. So that is letter C. So yung next application natin guys is work done in pumping. So for example, meron tayo ditong conical tank. So cone siya. So same lang guys yung formula natin, that is work equals force times distance. Then in fluids, we have a concept what we call the specific weight. So specific weight will be the force per unit of volume. So that is the weight or force per unit of volume. So therefore, you have F as specific weight times volume. So we have here work. So in terms of derivative, we can say that differential work equals. So yung force natin here guys is varying because you have here a varying volume. So differential of force times distance. So yung distance natin guys, say h na lang, h is the distance from the centroid of the fluid. This is the centroid to where it should be pumped. Let's say distance h. There are problems that it is pumped at a certain distance above the top of the tank, but sometimes it is just pumped at the top of the tank. So let's say h. So the reference point of your height here, of course, will be the centroid of your fluid. So yung centroid na guys, yung reference point natin. So we have here differential of force. So differential of work equals. So here, what varies is the volume because we have here a varying shape. So y differential of volume, so this is the differential force. So if you differentiate here both sides, this will become differential of force equals, so y differential of volume. So yung y natin here, that is the specific weight. So specific weight times h. So we integrate both sides, we have work equals. So specific weight is constant, it depends on the fluid which should be pumped outside of the tank. You have here specific weight integral of, you have here h differential of volume. So yung limit natin here depends on the height of the fluid. So yung limit depends on the height of the fluid in the tank. So yun ang limit natin guys. And h here depends on your distance of the centroid to where it should be pumped. Specific weight, that is integral of h dv. So let's say h1 to h2. So this will be our concept. And yung differential volume natin guys here is the topic we have discussed before. So in this first problem guys, we have how much work is required to pump all the water from a right circular cylinder tank 9 foot tall and 8 feet in diameter if it is emptied at a point 1 foot above the top of the tank. Water is actually pumped 1 foot above the tank. So dito siya ipapump. So this is 1 foot height. So the fluid in the tank, that is water. So H2O tayo. So the specific weight of water by standard, that is in English tayo kasi our given is in English. So that is 62.4 pound-force per cubic foot. Work equals, so the integral of, so specific weight differential of volume times yung height natin from the centroid to the top where it should be pumped. So let's say the height of the centroid from the base of the cylinder, let's say it is y, at y distance. Now, so the distance from the centroid to the top where it should be pumped is equal to, you have here, so if this is 9, so this is 10, this is height 10. So therefore this height here from the centroid is 10 minus, so this y. So distance y from the base to the centroid of the cylinder. So work equals, so integral of, specific weight natin is 62.4. So ilalabas na natin yung constant. So work equals, so 62.4 integral of. So differential of volume natin guys. So ang strip natin here is horizontal. So this is our radius x. So this will be our differential of y. So if we rotate this here, makabuo tayo ng cylinder din. So that is pi. So base times height tayo. Area of base, so that is pi times radius x squared times height niya, thickness dy times h. So yung h natin dito guys is distance of the centroid of the fluid to the top of the tank where it should be pumped. So that is 10 minus y. So in here guys, ang x natin which is the radius is constant siya. So cylinder kasi, if cylinder, constant yung radius niya all throughout the height. So that is 4. So yung radius niya is 4 feet kasi yung diameter is 8. You have here work equals, so 62.4. So yung pi, ilabas na natin. Pi, then yung 4 squared, ilabas na din natin. So 4 squared. So 4 is the radius. So constant siya. You have here integral of, so 10 minus y, differential of y. So yung limit natin is the fluid in the tank. So yung fluid in the tank guys is full siya. So therefore it is from 0 to 9. So this is at height 9. So 0 to 9. So you can use your calculator or you can perform this power formula. So you have here guys, so 155 to 60. Answer natin guys is in terms of pi. So i-divide natin sa pi para makuha natin yung multiplier niya. So this will become, so 49421. So work equals, so 49421. So that is pi. So unit is, of course, English tayo guys, that is foot-pound force. Now, alternate solution tayo. As I have mentioned before, that work is actually equal to your force times distance. So yung distance natin is the distance of the centroid of the fluid to where it should be pumped. So yung force natin is specific weight times volume. So here, meron tayong cylinder. So ang force natin is equal to, so you have specific weight, so 62.4, that is pound force per cubic foot, times ang volume natin, so cylinder siya, so pi d squared over 4, so that is the area of the base. So yung diameter natin is at least 8 feet squared all over 4 times yung height natin na 9 feet. So by dimensional analysis, this is pound force. So force natin is equal to, so this is 28229.095. So this is pound force. Then so we have here our tank. So the centroid of the tank, of course, is at 1/2. So if this is 9, so this distance, the centroid, cylinder siya kasi, so this is 4.5. So if it is pumped 1 meter at height 1 meter above the top of the tank, this is 1. So therefore, the total height where it should be pumped is 4.5 plus 1 foot. So that is equal to 5.5 feet. So our work is equal to, so you have force 28229.095 pound force times yung height natin, that is from the centroid, so 5.5 feet. So work equals, so same answer tayo guys, 155,260. Or in terms of pi siya, so divide natin sa pi, so that is 49421. 49421 pi. So that is pound force feet, so foot-pound force. So let's solve guys, next problem tayo. So in this next problem guys, we have a 5 meter high conical tank. It has a radius of 2 meters and is filled with a liquid of 800 kg force per cubic meter. So yun ang specific weight niya. So how much work is done in pumping the liquid at a point 3 meters above the top of the tank? You have here conical tank naman siya, guys. So, cone, so yung height niya, so that is 5 meters. Then, ang radius niya, top radius is 2 meters. So, of course, ang work natin, that will become force times the distance. So, work equals, so that is specific weight integral of differential of volume times height. Now, ang height natin, guys, is the distance from the centroid to where it should be pumped. So, yung height natin, height of pumping is, you have here 3 meters above the top of the tank. So, dito ang discharge niya. So, if the centroid of the tank is at distance y with respect to the bottom of the tank here, so ito distance y siya, let's assume na yung height of the centroid from the bottom of the tank is at distance y. Therefore, this distance from the centroid to the top where it should be pumped is, you have here 5 plus 3, so this is 8. So this distance will become 8 minus itong y. So this distance. So itong h sa formula natin, guys, is the distance from the centroid of the fluid to the point where it should be pumped. Yung differential volume natin is taken from our differential strip. So ito yung differential strip natin. So this is horizontal. So this is differential of y and this is x. So i-rotate natin here. So makabuo tayo ng cylinder shape. So ang volume niya is, you have here pi. So same lang nung process natin when it comes to volume by integration, but here wala tayong x right minus x left or yung distance of the radius ng strip because we don't have curves here. So itong simpleng figure lang siya. You have here pi x squared differential of y. Then kunin natin yung x in terms of y because we have here differential of y na variable. So in terms of y, dapat yung x para isang variable lang in the right side. So you use ratio in proportion. So this top, so this is 2, radius niya 2, then height niya is 5. So this is x and this height is y. So by ratio in proportion, we can say that, so x over y equals, we have here 2 over 5. Therefore, x equals, so 2/5 y. Now, i-substitute lang natin, then we integrate. So, tapos na yung solution natin. Then, of course, yung limit natin is the height of the fluid. So, puno siya, full tank. Therefore, from 0 to 5. We have here work equals, so integral. So, here guys, ang pointers lang natin is, of course, ito, yung distance h, which is the distance from the centroid to the point where it should be pumped. So, dito lang tayo mga careless. Then, of course, using the ratio in proportion. And ito guys, the concept of this is yung previous topic natin, area of the base times height. So, ito guys, kung mapapansin natin, connected yung mga previous discussion as we go along our topic. So, kailangan natin ma-practice yung mga previous topics natin. So, work is equal to the integral of specific weight. Ilabas na natin. So, work equals, so specific weight. So, differential volume times h. So, specific weight, integral of differential of volume natin is, you have here, pi x squared dy. But h is, you have here 8 minus y. Then, x is integral of pi. So, yung x natin is in terms of y na siya. So, 2/5 y. So, that is squared differential of y. So, this is 8 minus y. So, this is equal to, so yung mga constant, ilabas na natin. So, this is 800 given. So, this is pi. Then, 2/5 squared. So, that is 4 over 25. So, times 4 all over 25. So, this is the integral of, so yung y squared, i-multiply na natin dito. So, y squared times 8. So, 8y squared minus y cubed. So, differential of y. So, ang limit natin is from 0 to 5. So, the height of the fluid. Then, ito, automatic, calculate na lang siya. Of course, power formula yan. You have here 68,000 pi all over 3. So, yung answer natin guys, in terms of pi siya. So, yung 68,000 over 3 is 22667. So, that is letter B. So, 22667 pi kilogram meter. So, ito yung answer natin. Letter B siya. So, yung work equals, so, 22667. So, pi. Unit is kilogram force meter. Now, alternate solution tayo guys. So, the reason why gamitan natin siya ng integral is because of the centroid. So, you cannot easily find the centroid. So, using your alternate solution by formula, so the distance of the centroid of this volume from the base of the cylinder is, so let's say y, so that is h over 4, where h is the height of the cylinder. In this case, 5 siya, 5. So, if this is the centroid, so the distance from the top of the cone to the centroid will become, so h over 4, so this is 5/4. Now, the distance to where the fluid will be pumped is at height 3 meters above the tank. So, therefore, the total height or distance, so work is force times distance. So, in this case, distance is, you have here 5/4 plus, you have here the height 3 meters. So, ipapump siya at height 3 meters above. So, therefore, yung total height, the distance from the centroid to the top where it should be pumped is 5/4 plus tong 3 meters. So, this is 4.25. So, meron tayong distance guys. So, good na yan. So, yung force na lang. So, force is specific weight times volume. So, specific weight given siya. Volume, of course, volume ng cone. So, force equals, so specific weight, 800 times volume. So, 1/3. So, cone siya. 1/3 area of the base times yung height niya. So, discuss natin to in solid geometry. So, you have here 800 over 3. So, area of the base is circle siya. So, ang radius nito is 2 meters. So, this is pi times 2 squared. So, pi r squared times height na 5 meters. So, i-simplify natin to. So, force equals, so this is 16,000 pi all over 3. Then, we apply this. So, work force times distance. So, pag-multiply lang natin yung dalawa. So, dapat equal siya sa 2267. 2267 pi kilogram meter. So, work equals, so force is 16,000 pi all over 3. Distance natin is 4.25 meters. So, work equals, so times 4.25. So, that is equal to, of course, 68,000 pi all over 3. Unit niya is kilogram force meter. So, itong 68,000 pi all over 3 can be expressed as, we have here, so 68,000 divided by 3. So, that is 22667 pi kilograms meter. So, this is our answer. So, yung lesson dito guys is, mas madali siya i-solve using yung mga formulas. But, of course, you need to memorize them. So, it's also important for you to know the concept of integration. Of course, if you forgot the formula, meron ka pa rin plan B. So, ganun yung discard natin guys. So, that's it. I hope that you have learned from this topic. So, yung mga pointers lang guys, ulitin natin. Of course, yung formula mo will start to the basic concept of work. Work is equal to force times distance. Na yung force natin is your specific weight ng fluid times volume. Kasi by definition, you have the specific weight is equal to the weight of the fluid all over the volume of the fluid. Now, yung distance natin, of course, the distance from the centroid to where it should be pumped. Those are the pointers in solving for these types of problem. So, ito na guys, yung last topic natin sa integral. In my next topic, I will be starting our differential equation. So, see you guys in my next video. Stay safe and God bless. Thank you for supporting this channel.